function-wise, we're going to learn a new kind of graph. Let's go back over the ones we've done already. A linear equation, the graph looks like a line. Quadratic equation, the line looks like a parabola. Good. A absolute value equation looks like a V. Good. If anyone missed that, it looks like a V. An exponential equation.
So that curve up.
Right. It goes like up slowly, or up slowly at first, and then it goes quick. Okay. This is the last kind of graph we're going to study. Yeah. They are rational equations, and a rational equation, remember rational is the fancy mouth word for fraction. So a rational equation's got variables in at least the bottom of the equation, if not the bottom and the top. Right? So we're going to start out with the very most basic kind, then we're going to add a little bit, and we're going to add a little bit more tomorrow.
Like what we always do.
Okay? Yeah, exactly what we always do. All right, so take a second and graph this basic parent function. It's like no frills, the leanest kind of function we can have. All right, so graph it by hand real quick, and then graph it on a calculator to see if you came up with the right shape. Okay, so if I plug in a -3 there, I get -1/3. If I plug in a -2, I get -1/2. If I plug in a -1, I get -1. If I plug in 0, what do I get?
0.
No. If I put a 0 in here, my board would explode, right? Because you're not allowed to divide by 0. So this is undefined. I can't graph this. Okay, if I plug in a 1, I get 1, then I get 1/2 and 1/3. Okay, so if I graph those, it would look like something like that. Okay, and then over here it would be okay, and if I plug that into the graphing calculator, that's exactly what I would get. Now be really careful because your graphing calculator does order of operations even if we don't, and so that means if I don't put parentheses around my equation, it won't graph correctly. Okay, this one won't really require parentheses because there's only one expression or one term on the top and the bottom. All right. Okay, this is called, I need you to write this word down because it's going to pop up again in your life, hyperbola.
What? Like hyperbole?
Nope, look at hyperbola.
So like mix hypotenuse with parabola. You get hyperbola.
Oh my god, that's not funny.
Okay.
You don't have to thank him, just stop throwing. Shut up, Dave.
All right, a hyperbola has, if you notice, it's going along great until it gets to there, and it stops and like hits a wall and has to bend down, right? Same thing here. It's going this way, then hits a wall, it has to go up. Okay? Think about why that would be. Why would, when we get to 0, does it not want to get to 0? Right, because I can't divide by 0. And what do you call those lines where it can get really, really close, but I can't cross it?
Asymptote.
An asymptote.
Wait, what was that, Hammer?
Okay? Now, for the same reason, I can't plug 0 in here. Is there a way to get 0 as y?
Yeah.
No. You think about it. If I'm not allowed to plug 0 in there, that has to be some number then, right? So there's absolutely no way to get 0 as y either. So I've got 2 asymptotes. Right? Don't lose half the lesson just laughing about that word. All right? So I've got 2 asymptotes. I've got a vertical asymptote and a horizontal asymptote. All right?
Hammer, how old are we? All right.
Okay. All right. So that is the very, very basic function. Okay? Now,
Wait, I have a question, seriously.
yeah,
What does hyperbola mean?
it's the graph of it's a graph that's broken in two, like this, with two asymptotes.
Thanks for clearing that up.
Really, I mean, just the visual is the best definition, just to be able to draw it. All right. So now, if we looked at the domain of this hyperbola, what's the domain of this one? Of this graph? What can x be? Everything but 0. So the domain would be that x cannot be 0, or all reals except 0.
0 never, ever, ever, ever.
Right.
Okay, we just said that.
In this equation, how about the range of this function?
All numbers except 0.
Right. Can't be 0 either, right? Because we got an asymptote there too. Okay. So y can't be 0 there either. Okay. Now remember, vertical and horizontal asymptotes are equations of lines. So what's the equation for the vertical asymptote?
Domain's your x, range is your y, right?
Mm-hmm.
You just. That's how they line up. Vertical.
Domain is x.
Shut up, Dave.
So what's the equation for my vertical asymptote?
Y equals 1 over x.
No. What's the equation? We just said that this is my vertical asymptote, right? So what is it? What's the equation of that line?
Y equals 0.
X equals 0.
Y equals 0 too.
Okay, not for vertical. Now what's the equation of the vertical, or the horizontal asymptote?
I have a question.
Yeah.
Wait, but the vertical is x and horizontal is y. Oh wait, no, horizontal is x.
I asked a question.
The thing that goes this way is
That's-
x. Going up and down is y.
That's the x-axis, right?
Yeah.
But not any horizontal equation is going to be y equals. What? What's your question?
How did you get x equals 0 again?
Because that's the equation of remember, all vertical lines have the equation x equals something. So in this case, it's x equals 0 because that's the line that it goes across.
No.
All horizontal lines are y equals, and in this case, it's y equals 0. Okay? I'm sorry? For this exact function, no. No. All right, but we're going to get a little trickier in that we've added, now instead of just having an x on the bottom, I've got an expression, and I've got a number outside the rational expression. Okay? So in that case, okay, you'll notice I have no coefficient here, it's just x, my coefficient's 1. The vertical asymptote is negative h in using this equation, 1 over x minus h plus k. Wherever this is, that h, the vertical asymptote is at negative h. So where's the vertical asymptote here?
Negative 3. No.
Yeah, it's negative h. H is 3, so negative 3, right?
Yeah.
Another way you could do it,
You said 3.
another way you could always do it, another way you could do it is anytime you set the bottom of your fraction equal to 0, it gives you the vertical asymptote. So another way you could do it is say x plus 3 is 0, so subtract 3 from both sides, x is negative 3. So either way, okay? So my vertical asymptote is at negative 3. Okay? Your horizontal asymptote in this scenario is k. Because obviously, remember we said this can never be 0, because you can't ever have 0 on the bottom of the fraction. So because this can never be 0, then you could never have 0 minus 1, so what number can y never be? If it's impossible to have 0 minus 1, then I would never have negative 1, right? Because 0 minus 1 would be negative 1, and that's impossible to have. Okay? So whatever this is becomes my horizontal asymptote.
Okay.
I've got these.
So there are my asymptotes. All I have to do then is draw in my hyperbola. Okay, what's the domain of this function? Right, all reals except -3. How about the range? Right.
So your domain is just your vertical
Right. Exactly. Oh, except, yeah, -1. Okay, so my vertical asymptote is at x equals -3. And my horizontal asymptote is y equals -1. Okay, pretty simple still, right? Okay, well, we're not going to flip it. Then tomorrow we'll flip it. The last one is if I've got an expression on the top and the bottom. Okay. The vertical asymptote, again, is just where the denominator equals 0. So I'm going to plug 3x minus 6 equal to 0. Let me do that in green so it matches. And then solve for x. Add 6 to both sides, divide by 3, and I get x is equal to 2. So my vertical asymptote would be at 2. Okay. My horizontal asymptote, this is a little bit tricky. My horizontal asymptote is just at a over c, just the fraction that the coefficients make. So in this case, it would be what?
6.
Nope. A over c.
2/3.
Right. 2 over 3. 2/3.
Why does it say?
Okay. Okay. So my horizontal asymptote would be at 2/3. And then I just have to draw my hyperbola.
So your range would be C, right? Or 3, right? Or your vertical would be 3, right?
No, my vertical is 2. It's whatever. Set this equal to
Oh, 0.
0.
Yeah, I got you.
Okay? Yep.
What can we do these videos?
You just go to YouTube and search for Archer Algebra 2.
Okay.
Alright? Alright, and the domain for this function?
2. Or
All reals except 2. And this range would be all reals except 2/3. Okay? The vertical asymptote would be what's the equation of that line? X equals 2. What's the horizontal asymptote?
2/3.
Y equals 2/3. Remember, it has to be the equation of a line.
So, question.
Okay?
Here we go.
Yeah.
So